Kia ora guys. I'm going to be going through the level 3 calculus external from NCEA. It's complex numbers from 2017. So this video is me talking through my process of how I answer these questions, and I will supply a PDF link and little links to different portions of the video in the description. So if you want to skip ahead to another question, look in the description. This one I'm going to cover question 1. So let's start at question 1a. So if u equals 2 plus 3i and v equals 1 minus 4i, find u conjugate minus 3v, giving your solution in the form a plus bi. So the first thing I'm going to do is see how this here has a hat on the u. So if we want to find the conjugate of something, all we do is we write the complex number out again, except we just change the sign of the imaginary part. So it just becomes 2 minus 3i. So then what we're going to do is we'll write this out. So I'm just going to write it out below here. It's probably easier. So I'm going to put u first. U hat is 2 minus 3i, and then it's going to be minus 3v. So I'm going to go minus, and I'll open a bracket. Let's put this in a bracket, just so it makes it tidy. 3, and what's v? 1 minus 4i. 1 minus 4i. Now it's pretty handy because in complex numbers, all of these are just going to follow simple algebra. All of the stuff that you've learnt in algebra over the years is going to apply here. So let's just expand these the same we would in any algebra question. So that stays as 2 minus 3i. Over here we're going to go negative 3 times 1, so it's minus 3. Negative 3 times negative 4i, so it's going to be plus 12i. Okay, so now we've got to find the like terms. So let's get all the real parts. So 2 and negative 3, together that makes negative 1. And then negative 3 and positive 12, that makes positive 9. And that's got an I attached. Is that in the right form? Yep, A plus BI. So that's the answer to question 1. Let's go down. 1a is negative 1 plus 9i. Okay, so now write 36 over the 5 minus the square root of 7 in the form a plus b root 7, where a and b are integers. So the first thing you'll notice is that there is a square root on the base of the fraction, or the denominator. So what we need to do is get rid of that, and to get rid of a square root or an imaginary part that's on the base or on the denominator, we just do the conjugate. So what we're going to do is we're going to get this 36 over 5 minus root 7. I actually like completing my roots so I know where it finishes. And then I'm going to multiply that by 1, but I'm going to write 1 as 5 plus the square root of 7, and then on the top the exact same thing, because 5 plus the square root of 7 over 5 plus the square root of 7 is just 1. So I'm multiplying this by 1, with the reason being that this is going to get rid of the square root on the base, or on the denominator. So let's do a big line over here. So my heart's telling me to do the bottom of it first, but I don't think I can bring myself to do that. See if we can get a straighter line, eh? Oh, not bad. Okay, let's do the top. So 36 times 5, so that's 150 plus 30, 180. And then 36 times the square root of 7. We're just going to leave that as the square root of 7 because 7's a prime number. So there's nothing that we can do in terms of surds to make it any prettier. So it's just going to be 36 times the square root of 7. We'll leave that like that as a surd. On the base, we're going to have to go 5 times 5 is 25. Now what happens is, because we've done like the conjugate of this, that negative 7 times 5 and the positive 5 times positive 7, they're going to cancel each other out. So all we're left with is negative root 7 times positive root 7. So that's going to make it a negative. And root 7 times root 7 is 7. Okay, so then 25 minus 7 is 18, which is a very convenient number. So let's split this up. So it's going to be 180 over 18 plus 36 root 7 over 18. Now those are convenient numbers because 180 divided by 18 is going to get me 10. And then 36 over 18 is going to get me 2. So that just becomes 2 root 7. Let's double check that I got that right. Nice. So that equals 10 plus 2 root 7. So some questions they may ask you what is A and what is B. So you can see here our A is 10 and our B is 2, and that looks like it's in the form that they're looking for, so that is completed. Okay, moving on to question C. Solve the following equation for x in terms of p. So I'm going to write this out because this confuses me, so I often write a little note. I'll write x equals some function on p. So we're going to have x by itself on one side, and then we're going to have an expression with lots of p's jumbled around. So that's the form we're looking for. So first thing is, if you've got square roots, let's just get rid of them by squaring everything. So let's square p squared, and then we square x minus 2. This, because it's the square root, the square is just going to get rid of the square root. Minus, and 5 squared is 25. And then we'll get rid of the square root there by squaring it, and that equals 0. So the next thing I want to do is I'm actually going to look at what it is I want to isolate. So I want x by itself. So because x is in this jumbled mess here, I'm going to need to bring that out. So let's expand these brackets. So that's going to become p squared x. And then p squared minus 2 is minus 2p squared. And then that's minus 25x equals 0. Okay, so I want it in terms of x, so I need all of the things that have an x involved. I'm going to need to group them together. But see how this has no x involved? So what I'm going to do is I'm going to move that to the other side by adding a 2p squared. So it's going to be, what's left over is p squared x minus 25x. Oy, getting some delay on my drawing pad, sorry. That's ugly. Oh well. Equals 2p squared. I have no idea if that's lagging. Okay, so again, we're looking to isolate x, but we've got this p squared x and a minus 25x. So minus 25 and p squared aren't that related. But what we can see here is that they both have x as a term. So what we can do is we can actually just factor out an x. So I'm going to get an x and pull it outside of a bracket. So x times what is p squared x? That's p squared. X times what is negative 25x? That's just minus 25. See now how I've got x by itself. It's generally what we're trying to do here. So once x is by itself, we'll just divide it by this whole bracket. And then it will just be x isolated on one side. So it's going to be 2p squared divided by p squared minus 25. And that is the answer. I personally, I like when I see p squared minus 25, I'm automatically thinking of the fact that that equals p plus 5, p minus 5, but it's nothing to do with the question. It's just something worth looking out for. Might be a hint for a future question, who knows. Yeah, but it doesn't matter. Okay, moving on. Okay, one solution of the equation z cubed minus 2z squared plus bz minus 30 equals 0 is z equals negative 2 minus I. If b is a real number, find the value of b and the other two solutions of the equation. Okay, so I have to find, so because it's this polynomial is cubed, that means there's 3 solutions. So that's one solution here, and there's going to be 2 others. Now, when you've got an imaginary solution or a solution that has an imaginary component, I'm going to actually label that. I'm going to call that Z1. You can automatically find another solution to the equation by just getting the conjugate of that. So if I just do Z1 conjugate, right, which is I get the real part, keep it the same, and then I just flip the imaginary part, that's already another solution to the equation. Alright, now there's several ways to go about solving these. Today I'm going to go with the method of, what I'm going to do is I'm going to find out what I can do with these two things. So what I'm going to do is I'm going to get this, I'm going to bring it over here, and I've got z equals -2, oh man, too much lag, minus I. So this is a solution to z. I'm going to set that equal to 0, right? So I'm going to have to move this stuff over. Oh, are you serious? Okay, I think this 2020 MacBook Air can't handle running OBS and some basic tablet driver. Okay, so what we need to do is we need to add 2 onto this side to move it over, and then we need to add 1 onto this side to move it over. So I can say for a fact that z plus 2 plus I is going to be one of the brackets in my factorized polynomial, right? And then so I can do that with this other bracket over here. So I know that also z equals -2 plus I. So I can find the other one of them by setting that equal to 0. So that's going to be z plus 2 minus I. So that's another factorized, part of my polynomial when I factorize it. So that's one bracket, that's another bracket, and there's going to be a third bracket, but I don't know what that one is yet. So what I'm going to need to do is I'm going to say, well, this bracket times that bracket times the third one is going to get me this solution. So in order to do that, I need to expand these. So I actually like to use a table method to expand. So what I'm going to do is I'm going to make up a table here. Oh, that is just not sufficient, is it? Oh, you serious? Yeah, here we go, here we go. No! I feel like I'm definitely going more to the left. I can see a little grid on my drawing tablet and it's way straighter than that. Anyway, let's fix up a little bit more because I don't want this corner being ugly. Doesn't help too much. Okay, so I'm going to do this one here going down the side. Doesn't really matter where I do it. z 2 I, they're all positives. And then I've got here z 2 and -I. So what I'm doing is I'm just expanding these two brackets, but I'm going to use a table because I find it a lot easier. So that makes z times z is z squared, 2 times z is 2z, z times I is -zi, 2 times z is 2z. Notice that the diagonals match up, but we'll look at that in a second. 2 times 2 is 4, 2 times -I is -2i, z times I is zi, 2 times I is 2i, and I times -I. So what happens there is I times I is -1, so -1 is just a +1. So expanding those two brackets, we are going to get these things here. So I want you to just notice a few matchups. I'm going to go with a highlighter here. Notice that this corner matches with that corner and they cancel each other out. Notice that this imaginary part also cancels out with that imaginary part. Therefore, getting rid of all imaginary parts, which is very convenient. What other matches have we got here? So we can see here that this diagonal matches and this diagonal matches. So let's go back. So we'll start with our highest power. Z squared plus 4z, the green matchup, plus the other green matchup, plus 5. And that's the expanded version of these two brackets. So we know that it's going to be that times some other bracket that we don't know is going to get us to this answer up here. So let's have a think about that for a second. So see how I've got z cubed here? Z squared is going to have to be multiplied by a z in order to get that z cubed. If that was 2z cubed, then I would know that this would be 2z. But in this instance, I know that that's going to get me my z cubed easily. Now, another thing, so this is a good one to look at, and I also like to look at, I'm going to do that in red. I also like to look at the last number. So see how we've got negative 30 there? So I'm going to need to do positive 5 times something, which is going to get me to negative 30. So it turns out that negative 30 divided by 5 is negative 6. So that there is actually it. This is the other portion. So I now have z minus 6 being equal to 0 as my other bracket from here. But first, before we do that, maybe I should just check that it works. So how are we going to check that it works? We're going to have to expand this out. So what we'll do is I'm going to do another table down here. I always like expanding with tables because it's easier to check your work. So I'm going to put my 3 from this one along the top, z, 4z, 5, and I'm going to put z and negative 6 on the left here. So z times z squared is z to the power 3, z times 4z is 4z squared, oh that's an ugly z, that's going to get us 5z, this is going to get us negative 6 z squared, this is going to get us negative 30 z, and this final one is going to get us negative 30. Oof! I've made a blundering error just then. What is 4 times 6? Oh. Yeah, 4 times, oh no, yes, yeah. 4 times 6 is actually 24. So I don't know what the heck I was doing there. So that's going to be negative 24z. Nice. Okay. So let's, I'm going to show you that link thing again. It's kind of cool. So notice that these diagonals match up, and notice that this diagonal matches up as well. So we'll write out the full expression below. It becomes z cubed minus 2z squared minus 19z minus 30. So let's just see if that matches up. So up here, z cubed matches, yeah. Negative 2z squared matches, yeah, nice. B z is actually what we've just found. Well, let's just check the last one matches, yeah, negative 30 matches. So now we know that this value here, which I've underlined in green, is actually our B value. So let's write it over here. B therefore must be negative 19. And we got that from there. Oh, that's gonna, I'm just trying to fix that error without ruining my 9. Lovely, lovely. Okay, so let's go back here. So notice now that this is one of the brackets. So if we know that z minus 6, we set that equal to 0, we can easily solve that to mean that z3 is therefore positive 6, because we just add 6 to both sides. So now we've got our 3 solutions. The other 2 solutions are this one here, negative 2 plus I, and then our other solution is z equals 6. And we've also found the value of b just down here. So that is D completed. Let me just double check that I got that right. Looks pretty good to me. Okay, let's go down to the final question of question 1. Oosh. Find the Cartesian equation of the locus described by blah 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 blah. Write your answer in this form. What is that the form of? That there is the form of a circle. So I'm going to bear that in mind while I'm solving this question. So my final answer is actually going to come out as some circle on a page, or on, so they said it's Cartesian. Cartesian just means it's on like this 2-dimensional axis, and we generally put the imaginary part there and the real part here. So they're saying there's going to be some circle with the coordinates A and B, right? A and B. I'm pretty sure that should be a minus. So these going to be minuses? Yeah, we'll look at it later. And then it's going to have a radius of k. Well, it's actually going to have a radius of the square root of k. I don't know about this circle equation that they gave us, pretty wacky. Anyway, so we are looking, so don't be too, these two words are pretty scary. Cartesian just means it's on this plane, and locus just means that the number, the imaginary number, can be anywhere on this circle. So a locus just gives like a bunch of points where your possible solution can be. So don't be too confused by those words. Okay, so let's get this. We're going to have to do a bit of algebra by the look of it. Z. Let's replace Z. Let's let Z equal x plus iy. The reason we do that is because our solution needs to have x's and y's involved in it. Highlight them, eh? Yeah, because we're looking for x's and y's. We're not looking for a solution that has z involved. So we are going to have to expand out these z's to x's and y's. So let's do that. So it's going to be x plus iy. So we'll just replace that z there. Plus 2 minus 7i. And that's going to be equal to 2 times, interesting, x plus iy minus 10 plus 2i. Let's make that into a 2. Okay, now, first thing we need to do is understand what these fancy things here mean. This here is a modulus, right? So this is, if we have, I'm going to draw a new axis. So a modulus is all about the distance of an imaginary number from the center. So the whole idea with a modulus is you get the imaginary part and the real part, because the real part is represented by the red, and then the imaginary part is going to be blue. And we can just do Pythagoras theorem to find the hypotenuse, the green part. So the modulus is just this green part here. So what we're going to need to do with these is we're going to have to split them up into their imaginary and their real parts so we can do this operation. So what happens is you get your imaginary part, you square it, and then you get your real part, you square it, and you get your imaginary part, you square it, and then you just square root that, like Pythagoras. Whoopsies, I should probably do that outside. What I'm going to do is I'm going to pick new letters so it doesn't confuse you. So what we're going to do is we're going to find our real part. We get our real part, and then we add on our imaginary part, which will have a little I attached to it. And then when we're finding the modulus, what happens is we just square root the real part squared plus the imaginary part squared, and that will find us, oh man, this pad, it's not doing me wonders. I probably should have picked some flipping cool letters for that, but meh. Okay, so we're going to need to split this into real and imaginary parts. We're going to find the modulus of that, modulus of that. Okay, so our real part here is the x plus the 2. So should I split it up slowly? Nah, let's do it fast. So it's going to be square root, and we're going to get our real parts, which is x plus 2. And then we square that, and then we get our imaginary parts, which is y and a minus 7. So we'll add that on. And so that becomes y minus 7. Square that. So see how we've got real parts, imaginary parts, we square them, that will find our modulus there. Same thing over here, that 2, we'll worry about that later, we'll just leave it outside, don't worry me. That's going to be x minus 10, that's the real part. We'll square that, Pythagoras theorem, plus and we'll get our imaginary part, which is y plus 2, and that's squared. Okay, now this is looking, I'm going to actually get rid of that, sorry, because I'm going to need that space. It's looking pretty scary, but what do we do when we have blimmin' square roots? Just square everything, easy peasy. So we'll just square left side, so it's x plus 2 squared, just gets rid of that big as square root, plus y minus 7 squared, and that equals, remember when we're squaring this side we have to square the 2 as well, so that becomes a 4, and then we'll get rid of that big square root. Handy. I'm going to put it all in a big bracket because otherwise it's a little bit daunting. Brackets make life easier. Plus y plus 2 squared. Oh man, I need to give this computer a little break after this. Shucks, it's struggling. Okay, so what do we do to expand this out? I think sadly we're gonna have to expand everything. So this is just a lot of algebra. Okay, so x plus 2 squared, that's gonna become x squared plus 4. How is it not picking up on things like that? I'll stick with that 4. Beautiful. Plus 4. And then this one, y minus 7 squared becomes y squared. Ugh. Sorry, I'm not this laggy in real life. Minus 14y. I really want to have my equal signs aligned. It's not going to happen. 7 times 7 is 49. No, it's not straight. 4 outside a big ass bracket, x squared. Oh man, she's lagging bad. Minus 20x plus, no, don't fail on me now, computer, plus y squared plus 4y. No, it's like pooping out in front of me. Don't give up now. This is ugly. This is ugly as, by the way. I'm not happy with this. Let's. Yeah, I'm not overly joyed about writing this whole thing again. What I'm going to do is I just really can't be bothered writing everything on the left again. So I'm just going to expand this. 4x squared minus 80x plus 400 plus 4y squared plus, come on computer, 16y plus 16, and that's equal to all that stuff over there, but meh. I don't know if you can get away with this in NCEA, but let's give it a red hot go, eh? What I'm going to do from there is I'm going to whack everything on the side that's the largest, so that left side looks largest, so I'm just going to chuck everything over there. We'll deal with that as we go. Okay, so x squared, when that comes over, that makes it 3x squared. When that positive 4 comes over, it becomes a negative, so it's going to be minus 84x. And then, oof, now we've got to be pretty careful with these other numbers. What I'm going to do is I'm just going to bring the x's one over first. It just goes nice with that 16, doesn't it? How do I stop being ugly? I'm going to leave a little gap there actually. I'm going to go plus, okay, so I got y squared coming over, it's a minus, that's a positive y squared. So that comes over and makes that 3y squared. And then we've got minus 14 coming over, so that brings that up to 30y. Oh, it doesn't, this is probably grinding your gears so much. See how that became real thin? It's disgusting. Then, okay, so now a 49 and a 4 makes 53. So 400 minus 50, I'm going to go, yeah, 400 minus 53 is 347. And 347 get to 350 with a leftover 13, 363. plus 363. Now, common factor all through here. You should be able to spot it. If you don't spot a common factor, you've probably made a mistake. So I'm going to divide everything by 3. X squared minus, now 90 divided by 3 is 30. So 84 divided by 3 is going to be 28. I think. I hope. Fingers crossed. X. So I'm actually going to try and complete the square while I'm here. So negative 28 over 2 is negative 14. 14 squared is 196. So I'm going to add a 196 there. Now 3, so y squared divided by 3 minus 10y. Now we're dividing this by 3, so that makes 121. But we've got this 196 here that's going to be messing around with us a bit. But I want to make a 20 over here as well, because oh no, wait, no, it's not 20. That's going to be divided by 2, 5 plus 25. So what we need to do is 363 over 3 is 121. 121, we then got rid of a 196. And we also have to get rid of a 25. So we're actually going into the negatives here. I'm just going to add 196 and 25 together first. So I'm going to take 4 off that. So it's 221. So that makes negative 100. So we've got this unaccounted for negative 100 left over. Right, so what I'm just going to do is just drag it on this side, and that makes it into a positive 100. Sweet. Okay, so we've completed the squares. So now I actually didn't like their form at all, so I'm going to make it in my own form. It's going to be 10 squared, so we've got a radius of 10, equals, and these are completed squares that I'm dealing with now. I intentionally completed those. X minus 14 squared, and then this one is a completed square as well, and that's going to be y minus 5 squared. So that's now in the form of a circle. So we can actually draw that circle. So our x, so it's going to be 14 to the right and 5 up. So I'm going to go like this. So it's actually a circle. The locus goes 14 in the real direction, and it goes 5. Oh, whoopsie! It goes 5 in the imaginary direction. So it's like sort of like here. And so that's where the center of the circle is going to be, and it's going to have a radius of 10. So it's going to go down to like -4 here. It's going to go distance that way there. So it's going to sort of be a circle around there. Let's see how well this drawing pad does a circle, eh? Well, it's a great way to blame the drawing pad for my crap circle drawing abilities. Oh man, what a mess. I'm going around in a loop. What is this? Ah! Okay, yeah, anyway. That's the locus on the Cartesian equation. So it's a circle. So pretty much it means that this imaginary number, or the imaginary number that fits these bounds, is any number that can go on this perfectly drawn circle here. All right, so that's the answer right there. That'll get you an excellence. So that's question 1 done. Yeah, we'll do question 2 in the next video. I hope that wasn't too clunky. Sorry about the drawing pad issues. I'll try plugging it into power next time, but the light and the sound were way better out here. So yeah, thank you.